Welcome to the second edition of International Science Week. Here we group up two teams from several countries and make them work with each other to design a robot on the theme of science for peace and development. Let's meet our teams for today.
Hi, we're team 12808 RevAmped Robotics from Portland, Oregon, and Black Frog Robotics from team 56134 from Novi, Michigan.
So for the International Science Week, this is what our table of contents is for what we're going to be presenting today. So we're going to be presenting what the problem was, some background info about oil spills, pipes, and plastic waste, a solution, some 3D CAD models, and what our resources were.
The main problem is that oil manufacturing and transportation companies are not paying much attention to where some of the oil that they're transporting is going. Most companies see this and glance over it when they do this, leaving the environment to suffer because of the oil in the ecosystem. Because even small amounts, when ingested, can be lethal, not just to wildlife, but to humans if humans eat the wildlife that have ingested oil. Two examples of this terrible event are the Flint water crisis in Michigan that started in April 2014, and the water quality continued to stay toxic even when the community was frantically trying to remove the contaminants from the water by patching up the old leaking pipes that were exposing oil into the environment. Another example is that over the years, oil companies have known and have been covering up the fact that small percentages of their assets were leaking into the Gulf of Mexico. This was a huge problem as we are talking about big oil companies and their small assets were in reality deadly to humans near the Gulf and to the wildlife in the Gulf.
So this is the oil spills. Since 1986, on average 3 million gallons of oil is spilled per year in pipeline accidents. This graph shows the highest is oil substance which is spilled in from pipeline incidents.
This is some background information that we have on pipes already. So they're usually made out of carbon steel or plastic. Normally they're buried at a depth of 3 to 6 feet. And HDPE, which is the material we're using, is a thermoplastic pipe that's made from petroleum and is completely corrosion-free.
So here's more background info about pipes. So an average oil pipeline has a diameter of 30 inches. Oil spills mostly occur when there is a break in a pipe, and oil spills are extremely difficult to clean up, which is why it's important to prevent them from happening. So this diagram shows some details and specifications about on a 24-inch carbon steel pipe.
Okay. Plastic was first mass-produced in 1907. It's desirable for its flexibility of usage, which led to an overproduction of plastic. Plastic waste contaminates all of Earth's major ecosystems, and many major risks include adding to global warming and lethal inhalation.
So this is our solution. Replacement of carbon steel and PVC plastic pipelines with corrosion-free HDPE reinforced pipelines. HDPE pipe grade sheet has a higher molecular weight. This strengthening with its UV resistance makes it ideal for pipelines. Some other advantages of HDPE pipes are that it can withstand temperatures from -148 to 176 degrees Fahrenheit. It is fatigue resistant, it is cost effective, it is pressure rated, and it's resistant to most chemical. And I'm going to pass it on to Neil.
Thank you. So many plastics are known to release dangerous chemicals when exposed to extreme temperatures or degrade over time, causing dangers to the environment. And HDPE is not one of these. HDPE has the advantage of being extremely environmentally friendly, as it does not impact the environment directly, except if directly swallowed, which is not the case in our solution due to the size. HDPE, though, is also effective because it can be recycled. Now, one of the major problems that big companies face when they have to reinforce their pipes is cost. HDPE will not cost as much because when it's recycled, it can be recycled from material from HDPE that's already in the environment, but also that's already being produced through things like milk bottle caps. I'll pass it on to Catherine for the 3D visual models we've created to represent our designs.
Thank you. So here is a CAD of the straight pipe with a HDPE reinforcement. We did all of the CAD in Autodesk Fusion 360. So the gray pipe is a 24-inch diameter carbon steel pipe, and the white stuff is an HDPE plastic reinforcement. So like we mentioned in the diagram that we showed earlier today, the average 24-inch carbon steel pipe is 0.7 of an inch thick. And so I thought that if we were going to reinforce on the joints, we might as well make the reinforcement double the thickness of the pipe for extra protection. So the HDPE reinforcements are 1.4 inches thick, and they go over the joints of the pipe. So on the next slide, we'll give you more details about just the reinforcement. So here are some CAD renderings of just the straight reinforcement. Like I said earlier, it's 24 inches in diameter, and it's 1.4 inches thick. So this is the reinforcement for straight pipes. We also did this for curved pipes. So it's the same thing as the straight pipes, except it's curved. And so the pipe is still a 24-inch diameter pipe with 0.7 inch wall thickness. And the reinforcement has a 24-inch diameter with 1.4 inches of wall thickness. And so it goes over the curved joints for extra protection. And so here is some details about just the curved reinforcement. It's 1.4 inches thick and 24 inches in diameter, and it goes over the curved joint of the pipe.
These are the following resources we used while we researched our problem and were coming up with a solution. These citations were formatted using APA. These resources are all creditable resources. Thank you for listening and taking your time to listen to us. Any questions or suggestions?
Okay, I think I will have to leave the questions or suggestions for the YouTube chat. I would be very glad if there will be any, if you could actually respond to every one of them. Okay? Okay, perfect. Whoa, really great. You broke the rules a little bit, but I really think that your solution could be implemented in the real world. Like some of the robots presented in this event were more or less, I would say, easy to implement and actually usable in those situations. But your idea should really be easy and actually very useful. And why not? I'll give you a challenge then. Try to actually present this idea to an oil company. And try to get them to actually respond to you and tell you if they would be interested to do this. Because this will really solve some big problems this planet has and yeah, save lives. Actually save lives.
Thank you. Thank you. Yeah, in the future, provided the resources to further this project, yeah, we would most likely reach out to a company with some further research too.
Okay, thank you a lot for joining us. Thank you for the great job you did. And with this, I think that for today we're done. If you have everything else to say.
Thank you for listening to our presentation.
No problem.
And it was great to meet your team.
Yeah. Thank you for the call today.
Yeah,
Our
thank
pleasure.
you.
Thank you.
Thank you.
Our pleasure.
All right, thank you.
Thank you. Thank you. Thank you. Thank you.
Thank you.